Hey YouTube, Jay Kilroy here, back in the shop for a little project announcement. I guess this is kind of the official project announcement for the upcoming hydraulic press project that we're going to be doing. Some of y'all have seen in a previous video sneak peeks of the cylinder that I purchased on eBay, and I've got some more, at least another component that I'm going to talk to you about today, and then we're going to go over the computer and we're going to take a look at the CAD work for the frame and go over that. And then, you know, I'm going to leave this open for suggestion, discussion. That's always a big part of the videos. So let's get some stuff out here. The cylinder, which I'll show you here in a second, is an Enerpac 50-ton dual action cylinder, and bought it on eBay and got a real good deal on it. The pump is also an Enerpac. Let me get the pump out for you. This is the pump that I purchased. It's a Enerpac Turbo 2. The actual part number is, where's the part number? It's the PAMG 1405N, which is the largest reservoir available in this style of pump. It's a 4-liter reservoir. So that brings up a point. The cylinder that I bought, 50-ton cylinder, and it has 20 inches of stroke, which is quite a bit. I've been looking for a cylinder with long stroke because for certain broaching operations that comes in really, really handy. The downside to having a cylinder with long stroke is you need a high oil volume in your system. And while in a regular low pressure system, like a 3,000, 3,500 pound system, it's pretty easy to do. In a 10,000 pound system, if you go to Enerpac and you want to buy a pump setup with a large reservoir, they cost huge amounts of money. I paid about, I think I paid about $450 for this pump. It's a brand new Enerpac pump in the box. Interestingly enough, it comes full of fluid, and I thought that was pretty interesting. This is one that is valved for a dual action cylinder. So basically it's foot activated. You step on it here, and your direction is determined by this valve right here. It's not quite as fancy schmancy as a electrical control setup with solenoids and all that, but that's pretty much simpler and a lot less to break there. All right, YouTube, here we are back at the computer, and we're going to look at the CAD here, which I have up in front of me. This is basically a copy, to a certain extent, of an Enerpac 100-ton frame. Even though I only have a 50-ton cylinder, I certainly won't hurt to overbuild it, and if I ever decide to get another cylinder to increase the capacity, this thing will certainly handle it. I will make this CAD available as a SolidWorks model and as a DXF file for those that are interested. The link will be in the description down below. So this is a 1x6 uprights here with C15 channel. I believe a C1539 channel on the uppers and lowers here. With it's very simple, with some 1/2-inch plate, I I guess they call these spreaders, to use woodchuck terminology. And that is that as far as the frame goes. It's pretty straightforward stuff. And let's see, give you a different perspective here. Alright, here's up from the bottom. The only thing these are two pieces of C15 channel here that are in between the two bottom beams that form the table. I'm thinking about possibly moving these to the outside and opening this space up, but this is still a pretty good space. Where it's different from the Enerpac of the same size is it's 6 inches wider between the uprights, and it's almost twice the depth here as the Enerpac. The Enerpac has about not quite 7 inches between the uprights, and this has not quite 14 inches between the uprights. So it's much more a significant amount of space in here. But I was saying about moving these two plates, these two pieces of channel to the outside, forming a box all around the outside, but this is still plenty of room. So I would very much like any suggestions. Oops, excuse me. I would like any suggestions, comments. These are 2-inch pins, and I spaced the pins such that I could use 4 pins at a time if I wanted on the bottom or in this hole through the frame. I could just take this hole right here completely out and just use the pins under the frame, which I don't think there'd be anything really terribly wrong with that. But I haven't drawn in here anything to do with a lift system or anything like that. Give you some more dimensions. Interior dimension between the uprights is 40 inches. It's 48 inches on the outside, or well, 52 inches on the outside, given the 6-inch uprights. The Enerpac of the same size is about 35 something in that dimension. So it's like I said, it's a little wider. And the total height is 83.8 inches or so as it's drawn. I haven't put any feet on here. The only thing, I was originally going to build this as a bolted together assembly, and now I've decided, you know what, no, we're going to weld this snot out of it. You can actually add a significant amount of cost when bolting together an assembly with components this large. So when you go to buy 1-inch bolts, 1.5-inch bolts, it's not an insignificant expense. Plus, there's a whole lot of more hole drilling to do. So I believe it's going to be a weldment. I don't know that I'm going to weld it because I don't really have a machine that's ideal for welding material this heavy. I've got a 240 amp MIG, which is right borderline right here. That's the kind of machine you might use on, say, 1/2-inch material with regularity. This is all heavier than that, so I may get somebody with a larger machine, friend of mine with a big old stick welder or something, to weld this up for me. I may just get it all tacked all together and then let him weld it up. So anyway, this is the frame design. Let me pop the cylinder back up in here. I have not drawn any of the cylinder support structure, but as of yet, the cylinder support is going to roll along this top rail, and this nice model of the cylinder, courtesy of Enerpac, makes these things available on their website. So it's
kind of small there. Plenty of room for a larger cylinder, plenty of room for a low pressure cylinder. If I wanted, this is a 10,000 psi cylinder, and I can't say that I'm terribly enthused about that, but to get this kind of tonnage with say a 3,500 psi setup, you're looking at like a 7-inch cylinder. So there's still plenty of room in here if I wanted to put a cylinder in of that type or whatever at some time in the future. But this is definitely something I'm planning on keeping for a long time. So trying to make sure that I've got all my bases covered here. So anyway, love to get some feedback, love to get some suggestions. Again, look in the description for links to SolidWorks models and DXF files for this frame here.
So last but not least, here is the cylinder. Still in the box. Came with the Enerpac style, 604 style quick disconnects. And it's, like I said, it's 20-inch stroke, so it's about 2 feet long. And I think it's going to do a fabulous job, so can't complain here. There are 2 ways to mount. I could mount on the far end there by using the threaded nose, which is I think what I'm going to do, or I could mount on the back side, the top. There's 4 threaded holes in the base of the cylinder as well, but I think I'm going to use the threaded nose as the mounting. Anyway, so there we go. All right, so you've seen the pieces, parts we got so far. First question everybody has, well, why don't you just buy one? Right? Let's talk about the finances of building a press. The steel that you've seen in that CAD, well, delivered off the yard, $1,500. The cylinder, I got $1,500 in the cylinder. I got $450 in the pump. So I got $3,400 in the press so far. We don't have anything near a press. Baileigh sells a 50-ton press for $19.95. Probably gets delivered for a couple more $100. Now, what are the differences? It's got a 6-7 inch stroke. It's got a frame about this wide. I don't even think anybody sells a 50-ton press with a 20-inch stroke, but stroke length is what you pay for in addition to tonnage. You can get a pretty cheap 100-ton press if you're okay with 5 inches of stroke, which makes using it a real pain in the butt. And not as safe either. You see guys with things on a press and all sorts of shit stacked up on there, and they're pressing on it, and you're just waiting for something to come shooting out of there like a bullet. Talk about the economics of this. And then, what kind of decisions to make when you're building your own press? Well, my primary use of a press is broaching. 50-ton cylinder moves faster than a 100-ton cylinder, so you want a little speed, so makes broaching a lot easier, a lot smoother. You look at, there's a couple links I'm going to put up here to some videos by Keith Fenner. They were probably 2 years old. I think they were 2012, actually, now thinking about it, that's 5 years old. Wow. Time flies. Anyway, he goes into depth in 2 video series on his press that he had built previous to his YouTube career. And he has a lot of really insightful thoughts and comments about building a press and what you want in a press. He also goes into much more detail at this point in time about the hydraulics of his press rather than what I have. Talks about building it and everything. So anyway, I'm gonna put those 2 links here. Please check those videos out. I've already got more components on the way as we move through all this. This is gonna be a, buy some stuff, build some stuff kind of process. Be safe in the shop, and I'll be back with you real soon.